In this video, we're going to talk about the sine rule. The sine rule is a rule that relates the length of sides in a triangle to the angles that are opposite those sides and uses the trigonometric ratio sine to do that. So we can see the actual rule itself up here. It's a over the sine of a is equal to b over the sine of b is equal to c over the sine of c. Or it's the sine of a over a is equal to sine of b over b is equal to sine of c over c. Just for clarification purposes on this, the uppercase letters refer to angles and the lowercase letters refer to the length of sides. So all this rule here is saying is that the length of any side in a triangle over the sine of the angle opposite it is equal to either of the other two sides over the sine of the angle opposite them. In practice, we only realistically use two of these at a time, so we would only use two sides and their corresponding angles each time. We wouldn't use all three the way we've been shown in the rule. And what the sine rule can be used for is if we get a situation where we have a triangle, we've got two angles that we know and one of their opposite sides, and we want to get the length of the unknown opposite side. We can use the sine rule to do that. Or if we're given a situation where we've got the length of two sides, one of their opposite angles, and we want the other opposite angle, we can use the sine rule to get that. So let's take a look at a couple of examples where we use the sine rule to do just that, and we'll see what I'm talking about. So in these two triangles, you can see that on the one on the left, we've got two angles, one of their opposite sides, and the other opposite side is marked, but not with an actual value. And in the triangle on the right, we've got two sides, one of their opposite angles, and an unknown measure for the other opposite angle. So we're going to use the sine rule to calculate out our unknown side and our unknown angle. We'll start with our unknown side on the left here. So for this, what we're going to do whenever we're using the sine rule to do this is we're going to put the variable that we do not know, the one that we're looking for the value of, in the top left of our equation that we form. So in this case, a is going to go in the top left of our equation, and underneath it is going to be the sine of the angle opposite it, which is 60. So it's going to be a over the sine of 60. And that's going to be equal to 10 over the sine of 40. Like that. So far so good. Now we aren't going to work out the sines for 60 and 40 just yet. There's no need to do that yet. It'll only turn it into a long and awkward sum if we do it that way. Instead, we're going to do a little bit of movement with some algebra to get a on its own. So we're going to have a is equal to, and we're going to move our divide by sine 60 from the left and bring it over to the right side of our equation where it's going to become multiply by sine 60. So we're going to get 10, a is equal to 10 multiplied by the sine of 60 all over the sine of 40, like that. Now what we're going to do is we're just going to stick this sum on the right of our equals into our calculator to get a value for a out. And when we do that, we'll get a is equal to 13.47296355. Now typically if we're given a question on this, we'll be asked to round our answer to a given number of decimal places. But I'm just going to leave it like this for the moment. In our second triangle, we're looking to get the measure of the angle A. So we're going to put that in the top left of our equation that we form in order to get this solved out. So we're going to put the sine of A all over the length of the side opposite A, which is 16. And that's going to be equal to the sine of 50 all over the length of the side opposite that, which is 20, like that. And we're going to do a similar move that we did before in order to try and get a on its own. So we're going to bring our divide by 16 on the left over to the right where it'll become multiply by 16. So we're going to get sine a is equal to 16 times the sine of 50 all over 20. Now from this point, there's two different ways we can go about doing this depending on how comfortable you are with inputting the information into a calculator. Okay, so the first way that we're going to look at is if we actually work out this sum on the right and get a number for this. So we're going to say sine A is equal to, and if we work that out, it's going to be 0.6128355545, like that. And then in order to get the value for A, we take the inverse sine of that number. So A is equal to sine inverse of 0.6128355545, which means A is going to be equal to 37.79481563 degrees. Right, now that's one way we could go about doing this. The other way will get us the same answer, and it'll do so just a little bit quicker. So instead of actually working out our value to the right, what we could do is we could straight away say that A is equal to sine inverse of 16 sine 50 all over 20. And we'll jump straight to our answer without having to retype a long decimal. So we get straight to A is equal to 37.79481563 degrees, like that. One way or the other, we're going to get to the same answer. But the main point about all this was that when we are forming our equation to try and find out either the missing side or the missing angle, the side or angle that we are looking for goes in the top left of our equation, and then we just have to do a little bit of algebra and a little bit of calculator work in order to get our value out for our side or angle. And that is that.